Okay, in the last video, I just went through the answers, and as I was looking at the video to make sure it was okay, I noticed that the answers weren't on the page while I was doing them. So I just want to make sure everybody got the 4 answers. I think you can tell from up here what they each are, but I just wanted to make sure. And again, we knew there were going to be 4 answers because look at the highest power of the polynomial. It's 4, so that guarantees us 4 answers. And then I started to write your homework over here. I thought this was the last page of 7.3, and there's one more page, so I'll write it on the next page. Okay, let's go ahead and turn over to page 14. So I started working this problem out because, and then I got interrupted by the door, so I had to stop the video, so I'm starting it again. So some of it's already going to be written down. So we learned about these problems in chapter 5. So anytime you have an x in the denominator of a fraction, you always have to write a restriction list. And we learned how to solve these by multiplying everything by the LCD. So those are our first 2 steps. Decide what x cannot be, and then pick an LCD. So does everybody agree x cannot be 0? That's the only thing that would make these denominators zeros if you put 0 in. And the LCD, we learned, write everything you see, but only with the highest exponent. So I see an x, I see an x squared. X squared is the highest exponent. So the LCD is going to be x squared, and the restriction is going to be x cannot equal 0, which we have there. So that's always the first thing you do whenever you have a fractional equation and you have x's in the denominator, or y's, or any variable. So then the next thing I taught you to do was write the problem larger. So I rewrote it, and then I'm multiplying every single term by the LCD. So this term's going to turn into 6x squared. This term, one of the x's will cancel because 2 minus 1 is x to the first, so that's going to be 5x. And on this one, the x squareds are going to cancel, so we'll just have 6. So here's our new problem. 6x squared equals 5x plus 6. So we know that we have to have it set equal to 0 before we can try to factor or use the quadratic formula. Either one requires it being set equal to 0. So let me move this over just a little bit so you can see everything. Okay. So that means we want to always keep our x squared term positive. So that means these two need to move over. So that'd be minus 5x minus 5x. And then this one we have to do the opposite too. So minus 6 minus 6. So my new problem, ready to be factored or quadratic formulaed. Is that a word? Quadratic formulaed? No, it's not. So there's my new problem. So does everybody remember how to check to see if it's factorable? What kind of factoring is this? AC, right? Because the leading coefficient's not 1. So we want to know, are there factors of 36 that subtract to 5? Switch colors here. That one's running out. So factors of 36 that subtract to 5. So 1 and 36 doesn't subtract to 5. 2 and 18 doesn't subtract to 5. 3 and 12 doesn't, but 4 and 9 do. So 4 and 9 subtract to 5. And remember, we don't put our signs in yet. We first find factors that either add or subtract to whatever that number is. Then we look at this, and this says the signs will be different. And this says make sure you make the larger one negative. So that's going to bring us to different signs, largest negative, positive 4, negative 9. And remember, just like we did on the last page, anything that has AC in it, we have to take that term out and replace it with those two. And when you add those, 4 minus 9, you should get that. When you multiply those, you should get 6 times negative 6, negative 36, which is correct. Okay, so let's take it out. I'm going to put my negative first. So 6x squared minus 9x plus 4x minus 6. And the reason I like my negative first is because then I don't have a negative GCF. That's where a lot of students make mistakes. So anytime I have one of each, I just put the negative first. So 6x squared minus 9x plus 4x minus 6 equals 0. And this is called AC grouping because after we do the AC method, then we group. So the GCF here would be 3 and take the smallest exponent, x. So divide each of those by 3x. And we get 2x minus 3. So x's cancel there, and we subtract 1x there. Then we bring down the middle sign, plus, and the GCF here is 2. So when we divide each of these by 2 and no x, because there isn't an x there, we get 2x minus 3. And then we say, yay, look at, they match. So that's going to be my third GCF, the matching binomial. So I take it out of each term because I just pulled it out as a GCF. And then in my second parentheses, I write what's left, 3x plus 2. And my last step is to apply the zero factor property. If a times b equals 0, then one of these must be 0. So I set them both equal to 0 to find out what the possibilities are. 2x minus 3 equals 0, or 3x plus 2 equals 0. Add 3, and we get 2x equals 3, x equals 3 halves. Whoops. Or subtract 2, 3x equals negative 2. So x is negative 2/3. And those would be my two solutions. So let's go up here so we don't take more of the room off the problem and write our two solutions. So negative 2/3 and positive 3 halves. So there was not one new thing on that problem. You did problems just like that on the Chapter 5 test. So that is actually a review. The reason they put it on this section is because they want you to do these problems and they want you to know what to do if you hadn't been able to factor. So the first one they give you is factorable. I bet you this one's going to be quadratic formula. So they want you to be able to look at it and go, should I factor or should I do quadratic formula? I can do quadratic formula all the time, by the way, but usually it's easier to factor. I don't know, that wasn't so easy. I mean, it was kind of long, so maybe quadratic formula is the fastest. I guess you should just do whatever you're best at. But always remember that this guarantees two solutions as long as one of them isn't in the restriction box. Neither one were, so I put them both in solution sets. Okay, let's go up to number 9. So this one is quite a bit different because it has the plus or minus. It still has the x's in the denominator, so I still know that I need an LCD and I still know that I need to write a restriction box. So we have two denominators with x's, so this one would become 0 only if I put 0 in it. This one would become 0 if I put 4 in it, because 4 minus 4. So those are the two values that I'm going to have to throw out if I get one or both of those for answers. LCD is a little bit more complicated because these two, although they both have an x, they don't have a factor in common. So the LCD is actually both of them. If it was x and 4x, then the LCD would be 4x. But because it's subtraction, we can't say this x is common with that. So it's going to be both x and x minus 4. So let's write the problem bigger. I'm going to leave room there, leave room there, and leave room here. So we have plenty of room to write. So now next to every term, I should put the LCD, which is x and x minus 4. And remember, I do it even when it's not a fraction, because 2 really is a fraction. It's 2 over 1. We just don't write it. And then I put the LCD by this numerator. So whenever it's a fraction, remember we put it by the numerator. Hopefully you haven't forgotten all that from before break, right? Pre-corona. Okay, so now's where the work begins. So nothing to cancel here, so we're going to be taking 2x and distributing it. So I'm going to get 2x squared minus 8x on the left side. So add 1 plus 1, x squared, and then minus 8x. Over here, we do have some canceling. The x's are going to go away. X divided by x is 1. So I'm left with 1 times x minus 4, which is just x minus 4. Plus, and here the x minus 4's are going to cancel. X minus 4 divided by x minus 4 is 1. So I'm left with plus 1x. And I'm going to keep that 1 there because I see I have some like terms here. So I'm going to keep the 1's in front. So let's simplify this side and then we'll set everything equal to 0 because we know whenever there's a squared, you have to set it equal to 0 to either do factoring or quadratic formula. So 2x squared minus 8x equals 1x plus 1x is 2x minus 4. Okay, so now we're ready to start bringing everything to one side. Remember, you want to keep your x squared term positive, so everything needs to move on to that side. So we do the opposite when we cross the equal sign, so that'd be minus 2x minus 2x, and we have to also do the opposite of 4, plus 4 plus 4. So my new problem is 2x squared minus 10x plus 4, and now we have our 0. So hopefully, like I do, your first thought is, oh, I wonder if this factors. So let's try. So we need factors of 8, and it's another AC, right? Because the leading coefficient's not 1. Are there factors of 8 that add to 10? We have 1 and 8, 2 and 4. Do either of those add to 10? Nope. So guess what that means? Plan A, factoring, not going to work. So that means we go to plan B, which is quadratic formula. And I see that I could divide everything by 2 if I want. So let's do that up here, see? And we can make it a little bit smaller to make the quadratic formula easier. So let's put a line up here. So when we divide everything by 2, and that wouldn't affected it factoring, by the way, because then you would have had factors of 2 that add to 5, and we don't have factors of 2 that add to 5 either. So no matter what, it didn't factor. And I'll show you on this next step. So this is 1x squared minus 5x plus 2 equals 0. So I just divided everything by 2, which is legal as long as you don't skip any terms. And are there factors of 2 that add to 5? No, 2 and 1 add to 3. So that means we jump into quadratic. And if you hadn't noticed there was a 2 common and you went into quadratic, that's fine. You'll get the same answer. You'll just have to simplify your radical more, where if you simplify it first, then your radical won't be simplified so much. So let's get it set up. A equals 1, B equals negative 5, C equals 2. And we'll write the quadratic formula and then we'll work out the rest on the next video. So opposite of B plus or minus B squared minus 4AC all over 2A.